Okay, so this is where we left off in 4.5. So we're going to talk more about accounts. We're going to talk more about accounts with interest. We did this problem. We already did this problem on Thursday. Or on Friday, I mean. Okay. So we're going to look at a couple others. Okay. So first thing you want to know is what equation you need. Okay, what formula you need. This says compounded weekly. So I need compound interest, but not the continuous because it would say continuously. So for all other compound interest, we have this formula. Okay, so that's the formula I need. That is one of the ones you have to have memorized. It says find T. Okay, I'm solving for T. So I need A, P, R, and N. So A is 129,500. P is 90,000. R 0.07125. And compounded weekly, that means N would be 52. Okay? So I'm putting all those in. All right, after I plug them in, I kind of want to look ahead at what I need to do to solve this. So I see that my variable is in the exponent. So I'm going to have to do the inverse of an exponential function, which means the log. Okay, so I'm going to have to do a log somewhere in order to bring that exponent down. Okay, first of all, I see that this here is my base of that exponent. That is just a number. It's not a very pretty number, and we're waiting to do the rounding to the end, but this is just a number. And so I'm just going to say like base B, but this is what I'm referring to here. Okay? All right, so I need to get this base by itself before I can do the log of both sides. So I want to divide by the 90,000 first. And so when you go to divide by the 90,000 on the left, divide these numbers, but do not round. So either keep them as it is or keep it as a reduced fraction. But if you look at the decimal when you divide those, it's irrational. It does not end. So you would have to, and I put 0 there, 90,000. You would have to round it. So I'm going to keep it as a reduced fraction. So you should get 259 over 180. 259 over 180. Okay? And so that equals this base here. Okay. So I'm going to take a timeout and let's look at an easier example so we can figure out what it is that we need to be doing. So this is just a side note over here. And I will eventually erase this. But let's say we were doing the problem 10 equals 3 to the 2t. Okay, let's say we were solving this. That's kind of what we're doing here. We have a number equals a base with my variable as an exponent. Okay, that's kind of what we're doing. Just these numbers are a little bit simpler. So to get to the 2t, I need to get rid of this base 3. So I have to do log base 3 of both sides. Okay, so I'm wanting to log base 3 of both sides so I could get that to cancel. Okay, because when I do that, I can cancel that and bring the 2t down. Okay, so and then I can get t by dividing by 2. So t would be whatever log base 3 of 10 is divided by 2. Okay. I would have to change a base to figure this out, and I'll do that on this problem, but just that gives me a t, and then we'll talk about the calculation later when we do that. Okay, so same general idea. This base is just a lot uglier than just 3. Okay, but we're going to do the same thing. So if I want to bring this 52 down, I have to take the log base b of both sides. So this is the base I have to use. Like I said, it's just not very pretty. Okay, but I'm doing the same idea here. Okay, so I'm going to do the log of base b, and if you want to write just a b here instead of this, that's fine. Just don't forget that what b is. Okay, eventually you'll have to use it. So that is base. I'm going to write it down here. 1 plus 0.07125 divided by 52. Okay, log base 1 plus 0.07125 over 52. Okay. So that was me doing the log of both sides. That's this step here, what we did for 3. Okay. Now, like I did over here, I can cancel log base b of b. Okay. And I can just have 52 on the right side now. So I'm going to have over here, I'll have log base b of 259 over 180, so on the left. This is just a number, okay? No variables here. This is just a number. We are just waiting to do our rounding to the end so we get the most accurate answer. It just doesn't look very pretty. So the 259 over 180 is the big number. It's what you're taking the log of. This and green, the 1 plus 0.07125 over 52 is the big. So that should be your little number. Okay? It's not very pretty. Equals 52t. Okay? And then finally to get t, I'm going to divide by 52. So I'm going to be able to do this whole calculation at one time. So t equals log base 1 plus 0.07125. Make sure you copy things down correctly. You don't want to have all this work written down and then accidentally write something down wrong. And third hour, I caught it, but I wrote 250 instead of 259. So I think you'd be pretty upset if you did all of that work, but you wrote one little number wrong. As long as you show your work and I'm able to see that, then you're not going to lose very many points for that. Okay, you maybe one. All right, so what we need to do now, and I'm going to erase this side note because when I go to save these, if you weren't in class, then this would be confusing why I'm doing this here. So I am going to erase this. Okay. All right. So I need to calculate this. That's what we're going to talk about now. Now, unless you have a new calculator, then you're going to have to do change of base here. So this part here. So. Well, I don't know if there's a question that says just to use change of base specifically, but if it doesn't tell you you have to, and you have a log base B button on your calculator and you know how to use it, as long as you show this written out, then you can use that. Yes.
Are you going to have that answer and then the exact, or like the rounded answer on the test?
If you just write T, like, I want to see at least up to this step here.
Okay.
Yeah, and then you calculate that, and then you have T is approximately. Yes, that is fine. Like, you don't have to necessarily say T equals. You could do it here. Okay, so change of base. I use natural log, so that's natural log of the big number of what you're taking the log of. So 259 over 180, and then it's natural log of the base. 1 plus 0.07125 divided by 52. Okay. Divide by 52. So this is what I can type in my calculator. Okay. Use everywhere you see parentheses written here, you need to have in your calculator. So when I start this off, I'm going to put natural log, or parentheses. I got to start with the parentheses here. So parentheses, natural log, and then it opens one for me, 259 divided by 180. So I got to close this parentheses, divided by natural log, and then it opens a parentheses. 1 plus 0.07125 divided by 52. Close the parentheses as that natural log, and then close the parentheses for the numerator. So you should have double parentheses after you type in this whole numerator. And then just divide by 52. And you should get T is approximately 5.11. Okay. Yes, Julie?
Why did you use the natural log for the testing that?
So you could use natural log or log base 10, but I use those because those are the buttons in the calculator. Okay. Okay. So a couple notes about this. If you have the log base B button and you write this part out and you know how to use your log base B, you can do that. You don't have to do change of base. Okay. Also, if you learned and you still remember in pre-calc, there's a way from here, you could do natural log of both sides, okay, and bring your exponent down. If you know how to do it that way, fine, you can do it that way too. This will say solve algebraically. So if you do guess and check, because I mean 5 isn't that big of a number. So let's say it's around the nearest whole number and you wrote 5 because you guessed and checked, so you got to 5. You will not get points. Solve algebraically. So the test is testing you on logs and exponents. So that's what you would be expected to use. Okay? All right, anyone need some help with the typing in the calculator? Like, not able to get the right thing? There is a question like this where you're solving for t, for the exponent, on your test and on solution. Yes. Yes. Go ahead and you can start on this one as I'm still walking around to help anyone that has problems with the calculator. Anybody else? Anyone else need to go to the calculator for the rest of them? Alright. So the first thing you want to look at when you're doing these problems is know what formula you need. So compounded continuously. Compounded continuously is your PE to the RT, or per, if you want to call it that. Compounded continuously. Two parts here. Both of them are talking about continuous interest. Alright, part A asks if they will meet their goal. So what variable am I solving for? A. And I want to know if A is 140,000. Okay, so I'm plugging in what they give and we'll see if they've met their goal. So their principal, the rate, and the time needs to be given to me. So 85,000 is the principal. The rate is 0.069. And then the time is 6. Okay? So use the time sign in your calculator when you're doing the exponent, not parentheses, because if you do use parentheses, then you have to do double, because you want to make sure those stay together before they're taken as an exponent. Okay, so nothing to solve for, so you're just typing this directly in. Yes?
So why would you need to do like 140,000 minus 85?
Because that's if we're doing simple interest, and that's if it just gets, I need to know what the actual just interest is.
So, like, you wouldn't have to minus it.
No. Okay, so this should approximately be, let's see, 85,000 to the So I have 128,592.86 kroner. Okay. So did they meet their goal?
No.
No. Okay. If not, find the minimum amounts they will need to deposit so they meet the goal in 6 years. So I'm still having continuous interest. This time though, what variable am I trying to solve for? I heard a few different things. P. So now 85,000 isn't going to make it. So I need to figure out, well, what is the amount I need to get to 140,000? The variable I'm solving for is P. It's just what I'm multiplying here. So I don't have to do any log of both sides. I just have to divide by whatever this number is, e to the 0.069 times 6. So we're still used to decimal places. I mean, this isn't American currency, but it's still a currency, so we'll use two decimal places. So I have 92,540.13. Don't you guys got it? Okay, good. So those examples, what we've done up through this point on this section, those are the problems where you'll have to have those formulas memorized. Okay, what we're going to look at now, the examples we're going to look at now, have some different formulas, but these are ones you do not have to have memorized. If you're going to use them, they will be given to you. So you can have annuities and amortization. So sometimes you have accounts where you make regular scheduled payments to. So that's called an annuity. And so that has a different formula because when you deposit those payments, that's going to add to your principal, thus giving your actual amount, your final amount, it's going to make that grow faster. Okay, so here is the formula. Like I said, you do not have to have that memorized. So this capital P, like cursive P, is what you're depositing, okay? What you're depositing. It's that regular scheduled payment. Capital R is your rate divided by the number of times you compound something. All the other variables mean the same thing. so I'm going to use that formula to answer this question on 42. So if I read through this problem, the question says, what quarterly investment amount? So what variable am I looking for? Yes. I'm looking for what payment, periodic payment. So I'm looking for P. Okay. So I need to identify A, R, N, and T. So what's A? Okay, good. R, so remember R is defined as your rate over N. So my rate would be 0.085, and then quarterly, compounded quarterly, N would be 4, okay? So go ahead and divide those. If it's a decimal that you don't have to round, then it'll be just easier, less messy to go ahead and divide. So 0.02125. So for capital R, I can plug in 0.02125. All right, and we already said was 4, and then how many years? 4. Okay. So 4,700 equals P over 0.02125. And then instead of the brackets, I'm going to just use a second set of parentheses because in your calculator it'll be easier to do that and then find where the brackets are. So 1 plus 0.02125 to the 4 times 4 minus 1. All right. So this fraction is being multiplied by what I have here in parentheses. Let's divide by what you have in parentheses. Four times 4 is 16. Okay, so I'll go ahead and write 16. Okay, P is being divided by 0.02125. So what should I do to get P? Multiply, okay? So multiply by 0.02125. So we can type this into the calculator. I'll do this part first, the division, and then I'll take my final answer and multiply it by 0.02125. So I'm typing in 4,700 divided by parentheses, 1 plus 0.02125. Close that parentheses, goes to the 16th, minus 1, and then you close your second parentheses. Okay? And then you can do times 0.0212. Okay? And you should get approximately, and this is US dollars, so 249.72. So deposit $250.72 every quarter. You can get your 4,740. Questions about that? So a lot of these we're just multiplying and dividing things. It's just a lot of typing into the calculator. So just work carefully, practice typing these in with the calculator that you will use. Okay? If you need help, let me know. Okay. Yes, you need some help. Okay. Okay. So I'm going to put this up, and then I'll come around if anybody else has questions about the calculator.
Yes, that's so
All right, so we have growth and decay for more things than just accounts that pay interest. So if we're just talking about growth and decay in general, then we can use these formulas. Again, you don't have to memorize. So Q, or Q of T, is your quantity, like the final amount. Q sub 0 is your initial amount. And then R is your rate, and T is time, but units vary. You can measure in more things than just years. The only difference between your growth and decay is that your rate for decay will be negative. That's what makes it decay. All right, when you go to plug things in, you're not doing Q times T here. This is Q of T. So this is one value. Okay, this is one number that you plug in for Q of T. So some of you guys mess that up when you are doing these problems, these word problems, like I was grading your quizzes. And when you did Q of T, you were trying to plug something in for Q and T, or you were trying to solve for T still. This is one number. It's like y. F of x, it's like just having a y here. Okay? Okay, so let's look at this problem. So part A, to double means if your initial was 120, then what's your final amount going to be? If your initial is 120, your final amount will be no, other way. 240. Yeah, we're just talking about your final amount of rabbits here. Okay. All right, so Q of T is 240. That whole thing is 240. Your initial is 120. And then I want to find R, and then, but what's T? Yes, 6 months. So we're measuring in months. That's fine. So 6R. So T is 6. Q of T is 40. And Q sub 0 was 120. Okay, so let's solve this. Note that your variable is in the exponent, so at some point we're going to do a log. Let's get base E by itself, so divide by 120. And that should give you 2. Okay. Base E, so you want to do log base E of both sides. Well, what's log base E? Natural log. This one is going to be easier than the last one because we all have a natural log button on our calculator. We won't have to do change of base here because we already have natural log on our calculator. Weights around. So the natural log E cancels on the right. So you have natural log of 2 equals 6R. And then to get R, divide by 6. Okay, so now you can do natural log of 2 divided by 6. It's also easier because we had numbers that were easier to work with. We didn't have that 1 plus or anything like that. So I got 0.116. It's a rate, so we want to do at least 3 decimal places. That's 11.6%. Okay. Find the number of months required for the population to reach 2,500. So we're going to use this as our rate for Part B. So this time we want to know how many months. So this time we're going to look for T. And I'm not using the 240 anymore. I want to know when the population will reach 2,500. And I would still use my initial amount, which was 120. And then my rate was 0.116. See? Okay. What should I do first now? Divide by 120. A decimal if you don't have to round, or a reduced fraction if you do. So you would have to round, so this is 125 over 6. Now what do I do? Natural log of both sides. So my variable is an exponent, so I have to do log of both sides. The base was E, so log base E, which is natural log. Okay. Natural log of E cancels. And then you have to divide 5.116. And we're talking about months. Let's round to just one decimal place. So we should get 26.18. Or if we round one decimal place, 2.2. What you guys got? Okay. So a little over 2 years. All right. We'll stop